In this video, we are going to do our first regression in R, a simple linear regression on the same data set that we looked at in the correlation matrix video. So I'm just working off the same script here. And by the way, I should save this. So if you are ready to save your file, you can just use this little disk icon. Now, I don't think you're going to be able to see this because the dialog box that pops up isn't being captured by my video software, but I'm just basically going to save this as a script. And scripts have the dot capital R. I'm just going to call it Davis dot capital R. And you can see that that's the name that I gave it up here. So all scripts in R just have that extension of .r. The other thing I didn't do in the first video with the script is use a pound sign, and the pound sign is going to show up as green, and anything that comes after it on that line is going to be green. And I'm just using this as a note to myself. It's a comment, and R will not run it. It's not a command, but it's really helpful to if you're going to save a file and reuse it in the future, maybe after memory has faded, then it can be useful to just add in comments to yourself to keep things organized and clear. And I used all caps here, but you don't have to. Just type whatever you want after the pound sign. So the basic way that we run a regression in R using the car package for some of the stuff we're going to do, but what we're typing here at first is basic R. It's not something you need a special package for, is that we are going to use the LM function. So first of all, we need to create a model. We're creating a model, like we've talked about. We'll call this davis.mod, but we can call it whatever we want. So we're creating a linear model, and we'll use the arrow, and we're using the LM function to create that linear model. And R needs a few pieces of information. It needs to know which of our variables is the outcome variable, the Y variable, and which one is the X variable. And so we start with the Y variable. So let's say that we wanted to predict somebody's weight from what the person said their weight was. Well, then our Y variable is weight, and then we're going to use a little tilde, little curly Q there, and then rep weight will be our X variable. So we want to know if we can accurately predict somebody's weight, actual weight, by knowing what they said they weighed. And then we have to tell that our Davis data set is where it should go to get the weight variable and the reported weight variable. So the pieces here that change are the name of the linear model that you're creating, the Y variable, the X variable, and the data set. So LM will always start this off, and then you'll put the data set here, and this is basically a formula. So it's telling us this is the thing we're trying to model using this variable here. So Y, so I can put this actually as a comment. So it would be model LM, just to show you that basically it's Y as a function of X, data equals whatever your data frame is. It's just so that you know that's what the format is for creating this. Okay, so we'll go ahead and run this. And it shows that it's been run. We now have an object, a linear model object called Davis mod, but it's not actually giving us any output, which would be weird if you were in SPSS or Jamovi. It'd be weird to run a command and not see any output. Now we can just sort of print this model, and you could do this the shorthand way by just typing the name of the model, or you could use the print command if you wanted to. But very quickly you'll get used to not putting print in front just to save some keystrokes. So if we do this, what we get as output is basically just a repeat of the formula that we built. And then we have two pieces of information. And these are the two most important pieces of information up to this point. But this is not a lot of output. So here we have the y-intercept, so that, that's the score on y that we would predict for somebody who has a score of 0 on x. And then rep weight, this is the x variable. So this is our regression coefficient. So this is B1 and this is B0. So from this, you could build a formula. So I can do that with a comment just so that you can see it here. I would never do this if I was actually doing this in R for my own sake, but it might be helpful that y hat is going to be equal B1 times x plus B0, right? And in this case, y hat is 0.927 times x plus 5.3363. So that would be the regression formula. And then if you wanted to predict somebody's weight from their reported weight, you would put the reported weight here and just do the math. Okay. This is not a lot of information, though, like I said. So the car package has a function called S, which is short for summary, capital S. And we can just ask for a little bit more. It's actually going to give us a fair amount more. So we're going to run that. And it has some of the same information, but some additional information. And there's a lot of this that we don't need to worry about right now, but I just do want to show you because we will be using this S function as we move forward. So again, it just tells us the formula that we use to create the linear model. And we do have these same two. You can see that there's the same exact intercept and regression coefficient here. But now each of these things are being tested for significance. Now we don't care about the significance of the intercept, but we do care about the significance of our regression coefficient because that's telling us whether or not this variable actually seems to have an effect on the outcome. In other words, can we actually predict or estimate somebody's weight based on what they tell us? You would hope the answer would be yes, even if it's not perfect. But you can see that it is significant. This p-value is in scientific notation. This is basically telling us it's got 6 decimal and then 16 zeros and then 2. So this is a super tiny p-value. This is a significant result telling us that, yes, we can significantly predict somebody's weight from their reported weight. We don't have to worry about this for right now. The R squared, which we've talked about in class for this simple linear regression, is about 0.7, a little bit below 0.7. So we're able to capture or estimate 70% of somebody's weight by what they say, which is actually not as high as you might expect. And also that the overall model is significant, which is not surprising because we only have one thing in the model, reported weight, and that is significant. So in a simple linear regression, if this is significant, the overall model will be significant as well.